Hello guys, welcome to my channel and let me introduce myself. My name is Arnav Goel and I'm currently in third year in Triple IT Sunipat doing BTech in CSE. So without any much further delays, let's start with the question. So the question is from what forces that is irreducible anagrams. So let's call two string SNT are anagrams. So when S and T are called anagrams, when if and only if there is a string S and if the string T, if we rearrange its symbols such that in such a way that S and T becomes equal, then we say both of them are anagrams. So we say T is reducible of S, anagram of S, if there exists an integer k greater than equal to 2 and 2k don't empty strings, that is S1 and this that satisfy the following conditions. If we write the string, so it should result out string S and this, and each and every pair of the partition of that we have done, they follow anagram of each other. So what is reducible anagram? So we have some string S and we have some string T. What we have done is we just rearrange it like see this. We have some S, we just rearrange it, and then we have done partition. Then after the each and every partition, if we rearrange, that is T1 and S1 becomes equal, T2 and S2 becomes equal, T3 and S3 becomes equal. If each and every part after rearranging becomes equal, then we can say that T is an reducible anagram of S. So see the condition of this. So if such string doesn't exist, let's suppose if we try to rearrange and this S1 is not equal to T1, but others may or may not be equal, then we say they are irreducible anagrams, irreducible anagram of S. So I have already told you this example, and meme gaga is irreducible anagram of S. So what we have to do? We are given like some a string and some Q queries. So with L and R, where S is equal to the length of the string S, that is more of S. For each query, what we have to do is to find if there we have to do is if there exists at least one irreducible anagram. So what is the input? That is I have already told you where L and R is like substring that we have given. So we will output if such irreducible anagram possible, at least one. So we will output with yes, else we will output with no. So how we will do this question? So how we will do? Let's come to the like first of all the basic thing that comes into mind like brute force you can say or brute force actually. So what is the string that we have given? Let's take this one. Uh, so this is the string that is given and what is like what intuition that we get from this here with some Q queries. So first of all, we will take that substring. Okay, I have taken that substring and what I can do. So what's the basic thing that comes into our mind? What if n equal to one? And yeah, one thing that is I forget to tell you that there should be a partition. Like there should be a partition that we can. That is k is greater than equal to 2. If the substring that is given is has length equal to 1, then it will always and always equal is a irreducible anagram since we cannot partition it more. That is case should be and must be equal to 2 at two substrings. Yeah. So for if there is length equal to 1, then we can say it is a irreducible anagram. Okay. What if n equal to 2? That means what can be the possibilities for n equal to 2? Like here, wait. Now n equal to 2 or maybe n equal to further on, there the size of it depends. Like what if what I wanted to tell you that what I wanted to explain you that is, wait a second, just let me recall myself. Yeah. So we already know that if the size of the string is equal to 1, then we will directly say it is a irreducible anagram. So what if this is the string is given? If we try to like make some t, rearrange and make some t that is equal to this, and this is equal to s. So if we try to make partitions, so it will always a reducible anagram. So when will an irreducible anagram will comes out? It will only and only comes out if we partition in such a way, if we partition in such a way that the number of characters in the first part or in the partition of that should the number of the frequency or the frequency should not match with the S1, like A, B and A. The partition is like this. So in the S, there are the frequency of A is 2 and the frequency of A in that is 1. So that is a reducible anagram because if we try to rearrange, that will not be equal to S. S and R T are not equal to each other. So that will become an anagram. So what intuition we can get from here? The intuition that we get from here is like frequency. Overall, we need some frequency because since we don't look like we don't do like try to rearrange and check and then check, it will like take it will be a little bit slower, like our time complexity will be greater, so we can't go with that brute force part. So we need some optimization. So what we can do is to take some frequency, then uh, we take some frequency and then we will check for that. So if the characters of both of the strings are same, like A and A, if there is no difference overall, so it will be not an irreducible anagram. So what if there are two different possibilities so far? So if there are two possibilities so far, like A and B, so we will try to do some. We will take some input cases and then try, like we can do that way, or we need to think for the general cases, like uh, if some random string is given, okay, if some random string is given, like this one and this one, okay, so what comes in our mind, like if when like if we are at I equal to 0, so what I wanted to tell you, like maybe I'm not able to properly convey my message, like what I want to tell you that our main goal is not to do many and many partitions at all. What our main goal is, if we can partition from the prefix side, I mean that, like if we can partition from here, and if this is if the partition, if we have done, and then we rearrange and it becomes an irreducible anagram. So our main focus is to make the prefix part an irreducible anagram so far, like this one, and this one. Our main goal is this. Our main goal is not like do k equal to n or maybe multiple partitions. That is not our main goal. So our main goal is to partition in such a way that it contains prefix only. If we need to prove only a prefix part is irreducible anagram so far. So if the first character is A, then we cannot put at any cost A, since I can partition up at here and this and this are equal, and the rest part will definitely be equal, since frequency of both of them will be same. So if there are two different characters, so I will go with B because we need some different character to put at all. We can't put A, as I will already tell you. So we will put B. Okay. So now our B frequency becomes -1. Then I cannot put A at here. So because AB and BA, both of the frequency of S and T if for the prefix partition is equal. So we can't go with this. So we will put B. So now what we can put A or B, or I will go with B. I will try to put B or A. You can think like, let's suppose we go with A. Then we cannot put A again. We will go with B. Sorry. And then, of course, we will go with uh, A. We can go with A. Then we can go with B. And so on if we try to do. Like, okay, so wait a second, just I think we should take some smaller example. It would be easier to tell for. So for this one, so I put B, then I cannot put A at all. Then I will go with B. Then I cannot put A at all. I should go with B since we have frequency of B is 3. Then I can go with A. Then since we only left with A, and A. Since like uh, how to uh, wait a second. Just I mean that how can we think like how can we make the prefix part as an irreducible anagram? Since we know that we can put at here A, B, and then A. Maybe A we can put, then we can put uh, A again, and then we have to put some A again, and then B and then B. Maybe this one. If we try to do, since the prefix part and the suffix part, like from here, if we do from here, like I equal to n minus 1, we check the partition if we do. They both are not irreducible, they are irreducible anagram. So the possible substring that comes into my mind may be this one. So if there are two strings, like if there are two different characters within a string S, so and the last character and the first character are no are same. Why I am saying so? Let us suppose, wait a second, uh, wait a second, it's really getting, wait a second. Since I already told you, we have to put B, then we can put B, and then we cannot put A, so we go with B. We are all done with B. So what if there is only this? I mean, what I mean by like if this is the string so far. Wait a second. So if this is the string, so we will put, I can put B only, I can put B only, and then I can put A. Okay, okay. What if A is again here? Then what should I put now? I will left with none. So we have to put A. And when we put A, see this. This is reducible, and this part is reducible. The I equal to n minus 1 and I equal to 0 to n minus 2, they both become irreducible. So when things are okay with when things like s of I and then s of n minus I, or s of l and then s of r minus 1 are, they both are different, then we can 100%ly say that irreducible anagrams will possible. Since you can see, like put B and B all and then A. If there is A again, then you don't have any option like B and B and then A. Then here the situations will become differ. Like you cannot rearrange that way. If you are thinking like I will arrange like this B and then A and then A. If you do like this way, then see this. In the middle part, the partitions, like in the middle part, the partitions can be if we do the partition, then they both becomes reducible anagrams. Like this and like you can see this and this way. What if there are three characters different? So let's suppose AA, B, AA, C, AA, B, AA. I know. Wait a second. Maybe a better example I should choose. This one. So what if the last character are both equal or are equal, and what if the last character is not equal? So In this case, what we will do, we will try to put all our BB at first, since the last vector, we will try to put all the frequency of that like PBB. Total of them are three, so we will try to put all of them, and then we will put C, and then A. The reason behind this, for we are doing this way since we need to put at the first character and the last character different. Here that is A, then we put B, and then B, then is A. And then we will put all our whatever it is. Since if we think for I equal to n minus 1 to I equal to 0, if we do, then there will always be a frequency B that is left behind. That is this one. Same with here. We will always left with the frequency A left behind. So this way we can say that our irreducible anagrams will always be possible. Uh, but for about if the last factor are equal, then can we reduce or not? Like n equal to 2 says for n equal to, sorry, for if there were two different characters, then we can say that irreducible anagrams never exist so far for that. If the last factor and the first factors are equal. And when for this one, like if there are three different characters, so what we will do, what can we do? For this one, we can do is to like we will note all the three different characters the way they are present, the way their order are defined in the string. That is let's suppose A C B A for this maybe yeah for this one. So A C B. So what we will do? We will do is like we will put our B first, then all B, and then all A, and then C with the last. The reason behind this is quite simpler. Since take if we take this partition, let's suppose if we take this partition. Wait a second. If we take this partition, then we are then yeah C is there, but there is the frequency of B is uh, the frequency of B is uh, not matching with that with S and T. They are not equal at all. If we take this partition, whatever the partition you will take, if you will try to do, you will never get equal for that if you do so. You can see what if we take this same with B, there's frequency of B is here is 0 and here it's 3, and if we do this, since C partitions C frequency are 1 and blah blah blah. Maybe you are thinking like what if we take C again at here, or maybe again C at here. Yeah, you can take this. Since we know that what we have to do is to first of all write down what our main thing, that is the order. It is A, C, B. And since C is first, then we will put it at the last, and the B order is last, we will put at the first vector. It is BB. Then A, and we will go with C. Since you can see there's 3C and here also 3C, but we will left with B. Whatever the partition you will try to do, you will never get equal at all. If we do with this way, it's a very good question. Actually, it requires patience and some of many input cases you have to take, and somewhat your intuitions will work on this. So I think you get this question. So we will let comes to the core part then. So we will take the dual vector where we will for each index we will try to store all the frequencies so far. Previous frequency plus the current frequency plus one. That is for I equal to 1 to I equal to n. Then j equal to 0 to j equal to 26. Try to put all the frequency at all. Then we will move take queries, and then we will move for queries, and then check so how many difference of characters are there so far. If um, if a equal to b, that is if the string, if the length of the string is 1, or if difference is greater than 2, since for greater than 2, whatever if the character if the last index character in the first index character are same or not, whatever the situation, the irreducible anagrams are possible, and for any difference equal to 2, then we can say that if such happens, so like the last character index and the first character index, they both are different, then we can say also the anagram is irreducible anagrams possible. Rearrangement can be possible, then we will see out yes, else we will go with see out equal no. Uh, I know the way I explain this question is maybe not good, since it is a good question and it I try my best to explain this question. I think if you have if you have any problem regarding my explanation, or if you have any doubts, so do the comments, and that's from my side. Bye.